Okay, so waves and sound. So you guys have covered about every single kind of motion, right? Anything that slides, spins, curves, anything like that. You guys can describe that, and this now includes anything that moves in a circle, not just spins, but also can move in a circle. And we talked about this during our lab on Friday, our springs and mass lab, that anything that repeats a motion over and over is essentially creating a wave, right? So in our lab, we had an example of we had kind of a mass that was hanging on a spring, and that mass traveled up and down, right? Over and over, up and down. And we looked at things like period, frequency. So all of these things, we've kind of already had our introduction to this. So that's going to make this very, very simple. If I were to plot the y direction, okay, for this mass on a spring, kind of moving upwards and then downwards, right? What I would have is something like this. So I would have my y direction, and this would time, and I just kind of graph this out. So remember, in y direction, we'll call this 0. We can call this like -1 and +1, something like that. Okay. And what's going to happen is over time, the mass is going to go up, it's going to travel back down, and then it's going to repeat this over and over. So if I plot this y position over time, it's going to go up, it's going to come back down, it's going to go up, it's going to go down, right? So it's only going sideways here. It's not actually moving laterally at all. This kind of motion forward is just because time is moving forward, right? So we're just graphing our y position over time. So I want to recap really quickly the different parts of our wave. So first thing here, okay, is going to be amplitude. This is amplitude. Amplitude is how high does this wave go, right? So amplitude is from 0 to +1 here. Whatever our height is, this delta y, this is our amplitude. So how tall is my wave? So my wave could be, if I had a larger amplitude here, maybe my wave could be even bigger. But the same, it's just taller. It's the same exact wave, it's just taller, right? That would be a higher amplitude. Or I could have the same exact wave, but shorter. Okay, this is the same wave, it's just one is stronger than the other. So my amplitude is just the height of the wave. I wanted to get that one out of the way first because we're not going to use it too much, okay? I just want you guys to know that changing my amplitude is changing my intensity, okay? So if I talk about a sound, okay, so for sound, anytime I have amplitude, what I'm actually discussing is loudness or intensity. Nothing about a sound changes when I change my amplitude except for how loud it is, right? You can have the same exact song playing and it doesn't change anything about the song. If you turn the volume up, it just makes it louder or softer, right? So that's our amplitude. Next, what we're going to talk about is my wavelength. Let me make this a different color here. So my wavelength, I'm going to write it up here. Wavelength. The symbol that I give this is lambda. Okay, so this is very, very straightforward. when it looks kind of complicated, right? Wavelength is a strange word, and we kind of use it in conversation and stuff. Wavelength as being like kind of an abstract term, and it has a weird variable also, but this is actually very simple. Is just it's the length of my wave. That's it. So how long is it? Like physically, from point to point, how long is one wave? Okay. And this is actually, in order for me to find the length of my wave, okay, I'll put this here. I need two identical points on the wave. Now they have to be identical, so not equal to the same number, but identical. Think about this. If I were to choose my first part on my wave right here, so at this point in time, what is the mass doing and where is it, right? So in terms of this mass hanging on a spring, so what I do is at this point right here, my mass is at 0 and it's moving upwards, right? It's moving upwards. It just happens to be at 0 right now when we take a picture, but I know that it's going up, so it's going to keep going up, right? So if I were to choose the next identical point, I can't choose this. You might think, oh, oops. Okay, you might think this is the next identical point, right? This is 0, right? But these are different. In the first point, my mass was at 0, but it's moving up. In the second point, my mass at 0 is moving down, right? And another way to look at this is that if I were to choose this point right here, what we'll do is everything in between these 2 points, I'm just going to copy and paste it over and over. If I can copy and paste this over and over smoothly, that's a wave. But if I do this, I have this part of my wave right here, and I'm just going to copy it over and over. So you see, it's not actually smooth because at these points right here, it has like a sharp jump, right? This is actually not a wave right here. This doesn't work for us. So this point is not identical to this one. What is identical is the next time that the mass is at 0 and it's moving upwards, right? The next time that happens is actually right here. Okay? At this point, I was at 0 and going up. At this point, I'm also at 0 and going up, right? So a good thing here is that if I actually have this piece of my wave, everything in between the 2 points, what I can do is I can copy that and I can paste it over and over. I might actually be able to do this. Oops, never mind. All right, that's not gonna work. Okay, so you can see here that I have my wave goes up and then down, and then if I copy that over and over, up and then down, up and then down, I'll keep going. So when I talk about wavelength, it's literally just what is the length between these 2 points, right? So if I take this and this point right here, what is this length? This is my wavelength. So let's say, for an example, if I said this is 1, 2, 3, 4 meters, okay, this can be 5, 6, 7, 8 meters. Um, then in between 0 and 4 is one wavelength. So 4 minus 0 is going to be my wavelength is 4. Okay, it's 4 meters long. That's how long my wave is. If I do the same thing for the second wave, same thing. It starts at 4, ends at 8. It's 4 meters long, right? 8 minus 4. So that's how long my wave is. Um, there's nothing more to it here. So the most common thing that I see here is students will just overcomplicate this, right? So just take the length of one wave. And remember that each wave needs to have two parts, right? It needs to have an up part and a down part, a hill, sorry, a crest and a valley, right? However you want to remember this, um, it needs to go up and then down. So that's our wavelength. So it's made up of two segments. Okay, the next thing here that we're going to talk about is wave speed. Okay, so wave speed. So I want to know how fast does a wave travel, right? And this idea is best expressed if we kind of think about being on a beach. So let's say, hold on, okay, we have waves. This is the beach, okay? And you are going to stand right here, okay? Right here, you're at the beach. And then what happens is these waves, over time, they're moving towards you. So when I talk about wave speed, it's really literally how fast is this part of my wave moving, right? Because you'll see it like it's moving over, right? It's moving from right to left. So as this goes on, you will um, the wave will kind of move over you, right? Just like this. So you're standing there, it goes up, it goes down, it goes back up, right? It has a certain speed that it's moving towards you. That is my wave speed, okay? And there's a few ways that we can define this, but one of the easiest way is just in terms of meters per second, right? So my wavelength is how many meters long is my wave, right? So what's the length from here to here, right? And then my frequency is how often is this wave hitting me? So if I know how long the wave is and how often the next one keeps hitting me, then I can use both of these and just multiply to get the speed. So this is just a different way of using the same exact formula that we had before. So this here, I just want to, this is my wave speed, or you know what, this is my wavelength, and this is my frequency. So just remember for frequency, this is number of oscillations per second. Oops. So for if we have our formula here, I can actually write this out. My wavelength, my unit, remember it's just a length, so it's meters, right? And my frequency is how many times does something happen per second? Now, all I need is just events per second, right? So this is going to be 1 over seconds or hertz. Or hertz. Hertz is just the nickname we give this. It just means 1 over seconds. That's it. And you can see here already, if I multiply these two things, if I multiply these two things together, I have meters times 1 over seconds. This is equal to meters per second. Perfect. Meters per second is my wave speed.